up like this and let it fall through an arc, I'll precess in this direction. If you watch my video on making the turntable, you'll recognize this wheel. It's a spare wheelbarrow tire and wheel, non-flat or flat-free, filled with polyurethane. And you'll notice on the scale here, it weighs 6.1 pounds. What I wanted to do was see if I could find a wheel that was similar, that had more mass in the outer part of it to give it a little more angular momentum. So I found this wheelbarrow tire. It's a fat type. It's about 4 inches across there. Slightly smaller in diameter. This one's about 15 and a half, while this other one was about 16 3/8. But this weighs 7.9 pounds, so it weighs a good bit more. I had to modify it a little bit further because this one doesn't have these ribs on it, so I could engage my spin-up tool. You'll recognize this from the previous video. So what I had to do was glued just some stainless steel bolts on here using JB Super Weld, and then I added a little bit of JB steel to help reinforce them. And this works pretty good. But over the axle shaft, when I put the axle shaft in there, this thing is spinning. It's a little hard to handle. So I came up with a copper sleeve arrangement, and see if we can show you this. This just slips over that. I put a fender washer up here and a couple of nuts, and this slips on that and works pretty good. We'll spin it up here and you can see what it looks like, and we'll give it a try. I've got a 2x4 with 5/8 inch hole drilled there for that axle shaft, just C-clamped to this old TV stand. We're going to set this in here like that. That way it spins pretty freely. I can put my spin-up tool on there like so. It engages that, and use the cordless drill to spin it up. And once it's spinning, I can just slip that off. Then I can grab hold of that axle shaft and do something with it. So we're going to go ahead and give that a try. You can see the tire's out of balance. It's not designed to be spun up that fast. It's just a wheelbarrow tire, but it does work. This video is actually a remake of an earlier one I did using a spinning wheelbarrow tire on this turntable. There's a link at the end showing how I made the turntable. Originally I had too much threaded rod sticking up. It was a safety hazard. Cut that off, redid that video. I'm redoing this one too, because this is now flush with the sides. It's much safer. You can't be totally safe standing on a spinning wheel, but at least it removes that particular tripping hazard. And also this is setting on this turntable is on a 400-pound shipping scale. It's accurate to 1/10 of a pound. I've checked it. It is accurate, but we're not doing anything with that weight information right now. There's some issues. There's some lag time in the scale, and I've got to take a little further look at that to see how to handle that. But if I get on this turntable, by the way, for a complete demonstration of gyroscopic effects you can get on turntable, please visit the link at the end of this to my bicycle wheel gyroscopic demonstration video. I go into a lot more detail about all the movements and everything you can make. I don't want to redo all that here. I want to focus on this rotational Newton's law thing. So, but I'm on here. If Newton's law, for every action there's an equal and opposite reaction. Like normally, if I pick this up and just suddenly raise it up, there should be, you know, at least a momentary extra push downward, and same thing if I'm over here, bring it down. And if I want to turn on this turntable, you know, you can see a third law effect like this, but I don't go anywhere. I just go to a certain distance and stop. I can't just keep rotating. And if I want to do that, I'd have to push against something like that, which I can do. I'm pushing against the tire. That's my action is turning, and the reaction, you know, pushing against that wheel. Most of us are aware of that. But with this thing spinning, you don't have to do that. All you have to do is let it precess, and if I force it against the normal direction of precession, it will also rotate, but in the opposite direction. By the way, for all this work with this drill I use to spin this up, my normal rotation direction is counterclockwise relative to the camera, which means the normal direction of precession will be this way. And if you were up top looking down on me, that would be counterclockwise. If you spin it the opposite way, the normal direction of precession would be that way. But since the drill normal turning direction for the drill without reversing it would make this, the way I do this would make this counterclockwise relative to the camera. So we're going to go ahead and spin it up and take a look and see what happens. Okay, now if I'm up like this and let it fall through an arc, I'll precess in this direction. Okay, that's normal precession. If I raise it up, force it against that, I do what I call an anti-precession this way. So when that's going on, what's it pushing against? There's something about this effect that allows you to rotate, and it does look like it appears to violate Newton's third law. Okay, it's important to note that a gyroscope has to fall to precess. Just holding it, you don't turn. Let it fall down, rotating out of that plane, and it'll precess that way. I'll force it up, do an anti-precession like this. Down, normal precession direction. Once it's fallen down, stops falling, the precession stops. There has to be room to move, like there is here. Or like that. So keep that in mind when you're looking at gyroscopes. They got to fall to precess. One thing I wanted to share is one of my mistakes. I got the bright idea that if a spinning wheel will turn me on this turntable, could I get on a skateboard and do a tight turning radius and have it propel me? So I got this skateboard. I think it was from Walmart, and never been on a modern skateboard. And as soon as I stepped on it, I went down like a ton of bricks. And I thought, I'm lucky I really did not seriously hurt myself. So until I learn how to ride a skateboard or put on some safety gear, that's for something in the future. But that would be fascinating if you could figure out a way to do that. So hope you enjoyed this. If you did, please like the video. Click on the round Anisotropic Plus subscribe button and check out other links. We'd appreciate it. Thank you very much.